Hello, how are you doing today? Today we are going to learn how to program your Crawley EV3 robot. So, before you start programming this robot, make sure that you have number one, built the robot with the instructional pamphlet that was provided, and also make sure that you read the secondary instructional pamphlet which taught you what each of these individual little programming functions mean. If you've not done that already, please pause this video, go do that, and then come back here as soon as possible. This video is only to show you how to construct the code and reinforce those concepts, not to actually teach you what all of this means. So, without further ado, let's hop straight into this. So, first thing we're going to do is I'm going to first build a little bit of the program, and then I'll tell you what I just did so you can understand the program instead of me trying to do it piece by piece. So the first thing we're going to do is insert this red guy right here from the variable section under the data operations. Then we're going to go to flow control. We'll insert this guy right here, this loop. We'll insert this weight right here. We'll change the weight from time to ultrasonic sensor because we're using that in our project. And then we'll click from change to distance centimeters. And then we'll go to this red bar again. We'll add another variable. Boom. So we'll take this variable, put it right there. We'll add this thing called the math. We'll add it right here. Boom. We'll take this variable right here again, and we'll add it in. So this essentially, for all intensive purposes, is actually the counter. And so you're probably looking at this and saying, well, how is this the counter? What does this even mean? Well, so let me explain this to you very quickly. So the green arrow is where the program starts. So our program starts, boom, hits this thing called variable. Now variable is essentially taking count of something. Well, not taking count of it, right, because it's not the counter, but the variable essentially is what has been triggered as a response of something. So there's no trigger, there's no response, so therefore there's no variable in this case, right? The variable is 0, right? Obviously, nothing's happened. So let me go into this loop. Now, so the purpose of this infinite loop right here, this is called an infinite loop, by the way, is to make sure that once we are done one set of the counter, it will come back, take that value, take the new value from the counter, put it back over here, boom, and then repeat the loop, okay? If we didn't have this in a loop, it would only be able to count up to one object, and then it would finish. So basically what the loop does is it allows us to count objects up to an unlimited amount. Cool feature of the loop is that you can actually set it to unlimited, or if you want to only count a certain number of objects, you can set it to count, and let's say you want to count 10 things. So let's say 10, we'll put in 10, just for our project, okay? So now I'll explain to you what this is actually happening here. So we enter the loop. First thing that happens is this weight ultrasonic sensor. What does that mean? Well, what this basically means is that nothing is going to actually happen in this loop until something has been scanned by the ultrasonic sensor. And so how does scanning with the ultrasonic sensor work? Well, the ultrasonic sensor releases waves, and these waves they hit a certain distance, and that distance is recorded as it returns back to the ultrasonic sensor. If this distance changes due to a disturbance, in this case an object being counted, then that distance will change and it will register a variable, right? So the variable is registered, and it is registered as 1 because it is the one disturbance that went through the wave. So it registers this as a variable over here. Now, this variable right here is going to be directly plugged in. Sorry, first it changes as read because it's reading the read numeric. It's reading the variable from this ultrasonic sensor, right? So first, it's going to read this variable, and then this variable is going to be plugged into this A slot right here, right? So the reason why we're plugging this into the A slot is because this is going to register this as one object, right? And so what this now does is that after this has been registered as a variable, it plugs into here, and it's going to add the old variable count plus the new variable count, which in this case is 1. It's going to add 1 because it's been triggered by this to add 1. This response right here triggers essentially something to add 1, right? So it's going to go into here, it's going to add 0, because we have 0 to begin with, plus 1, and then it's going to spit out a new variable number, right? In this case, it's going to write a new variable number. So we're going to hook this into here, okay? So what this essentially does is that first an object is counted. It triggers a response here to put in a variable. The variable goes into here, into this math function. This math function is set to add, so it adds plus 1. The old variable count was 0. There was nothing to begin with. So it adds 0 plus 1, and then it writes the new variable that will be displayed on the screen, which in this case will be 1. And so now we obviously have our loop, and this could essentially just keep counting and counting again over and over, right? And so let's say we finish one loop at 1. Well, now the loop is going to go boom, 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 boom. It's going to come all the way back over here. This now is going to be 1. This variable will be 1, okay? And so then it's going to register again, right? It's going to count variable, right? Boom. But this is already 1 in this case, right? So now it's going to go boom, 1 plus 1 is equal to 2. Then it's going to register the new variable. 2 is going to go here, 2 is going to go come back around, right over here, boom, 2, right? Then this thing right here is going to count another object, boom, it's going to go into here, register as 1. That's going to be, but this now is going to register the 1, right? But this is, sorry, it's going to register the 1, but in this case it's already going to be 2, so it's going to be 2, boom, 2 goes into here, 2 plus 1 is equal to 3, 3 goes into here, 3 is the new variable, 3 goes in back to the loop, and so on and so on and so on to infinity, right? We're doing this 10 times in our case, so we'll only do it 10 times. Okay, so now we need to actually display this on the screen. So how are we going to display this on the screen? Well, we're just going to leave the variable. We don't need to do any more changing of the variable. So we're going to add in another variable, right? Basically, it's going to take this variable and it's going to continue moving the variable along the chain or the path, right? And so then we're going to take this, right? This is the display function over here. We're going to plug in the display function. And so we obviously don't want this to be displaying an image. We want to display a number in pixels. Okay, so it's going to do this, and it's going to send it on MINDSTORMS. Well, that doesn't really help us because we need to have this variable, which is being this variable right here, which is being connected to this, actually outputting on our screen. So we're going to set this as a wired connection. The wired will actually allow us to drag. Sorry, the wired will actually allow us to drag this thing when it's set under read numeric from here to here. Okay, and so this is going to read. This will read this variable, put it on the screen as text. Cool. So now another useful function that I want you to understand is the chime function, because think about it, if we're counting something and we're counting a lot of objects, we don't want to keep looking at the screen to make sure that our robot has counted the object, right? But we want it to beep. The beep will actually let us, well, it'll let us know from its audio that the object has been counted. So all we have to really do is just attach the beep, right? The chime function. So this chime is set under hello, and we don't really want it under hello because kind of weird if our robot said hello every single time we counted an object. So there's a lot of choices different here, right? There's good game, there's Lego, and let's go to mechanical. Let's go to the mechanical noises, right? So we have mechanical, and let's say that we want to choose a certain sound. So for our sake, I'll choose blip 1. So that's the sound that it's going to make every single time an object is counted. And so basically all this means is that now, right, it's going to count, display the number on the screen, and then it's going to release a chime. Okay, and so the last thing that I'm going to do, just for the sake of this project, because this sensor right here, the ultrasonic sensor, is very, very, very sensitive. What this means is that as soon as it's done counting, it's going to have a small delay before it reaches this beep, right? But this ultrasonic sensor, if you even drag your hand across it one more time by accident, it's going to automatically count again, right? It's going to automatically want to count again, and so then the beep and the sensors counting will be off from one another. So what we're going to do to make sure that this doesn't happen is we're going to add in a delay before the loop restarts, right? And so we're going to add in a 1.2 second delay. This is done for the sake of the kit. This was already done and tested for the sake of the kit, and this is the correct time so that you have enough time to remove your hand, remove the object, and grab a new object before the loop resets. So that will provide a delay before the loop resets again. And so what this entire loop that we just created does is essentially, again, as I said, it takes in a response which is scanned in the form of a variable. And the variable, right, in this case, is originally 0. So 0 is added to 1 to produce our new variable 1. The 1 is then taken and transported along to this variable, which is reading this 1. It reads this 1 and displays it as text on the screen. When the text is displayed on the screen, a chime will beep, and then it will have a 1.2 second delay before this 1 that we just got from this loop is sent all the way back to the beginning. The 1 is sent all the way back to the beginning, and then is again counted as the new variable. The new variable is 1. So then now, again, so we have 1 right here. This triggers a response for variable. Variable in this case is now 1, as we know, because the loop resets, and this is 1. So now this is 1. It takes 1, it transports 1 along here, and again, when this is triggered, it will then count 1 plus 1 is equal to 2. 2 will then come over here and be our new variable. 2 will be transported along this variable to read that. This will read it as 2 and display it as text on the screen. 2 will pop up on our screen, a chime will sound, and there will be a 1.2 second delay before the variable 2 is sent all the way back to the beginning of the loop. And so that's essentially how you create a counter which will also produce a chime and text on the screen of our EV3 brick. So now the function of Crawley, or one of the particularly interesting functions of Crawley, is that you can actually make it count long distances. So how do we make it count long distances? Well, in your instructional pamphlet, you will have noticed that for this project, for the power of the motors and for the amount of rotations, there is a certain distance that Crawley will actually crawl. Now, if you program it on these specific settings, which I'll explain later, then the crawly will crawl a certain distance. You can wave your hand in front of the crawly. It will count how many times you wave your hand in front of the crawly, and then you can take that at the end, see how many times you waved your hand in front of the crawly, multiply that by the distance that it takes to travel one rotation, and you'll find the distance of how much you just traveled. That is the function of the crawly. You can measure actually quite large distances with this thing. Or let's say you need a specific distance, you don't have a ruler, or maybe your ruler is too small for the distance. This robot, it can actually serve that function. It's perfect for doing so. So what we know is that whenever something is counted in the counter, it's going to trigger the response here, right? And it's going to trigger the response after 1.2 seconds to boom, restart this loop, right? And this is infinite for however many times our loop is set to. So if we want to crawl every single time an object is counted, then we need it to essentially start at the exact same point, and we also need it to be an infinite loop. So we're going to add in another infinite loop, okay, right here. It doesn't really matter where you add it, you can add it anyways, right? So this is our infinite loop added in. And so what we have to do is we have to take this, because we want them to start at the same place, remember. So importantly, we want them to start at the same place. So we're going to take it in this, and we're going to make a new pathway from here to here. Boom, sorry, this is kind of, okay, cool. So now, that means that our loop will go here, it'll start, it'll come down, it'll go to this function, and it'll also go to this function right here. So we have two programs running simultaneously, right? So the key thing, if you're trying to measure distances, you have to make sure that this is set not on 10, but you want to set it on infinite, unlimited. Keep that as unlimited, and this one will also be kept as unlimited. They'll run side by side, okay? So again, we want the motors to be triggered by the ultrasonic sensor. So we're going to do exactly what we did in the first thing. So we're going to put this right here, right? And we're going to click ultrasonic sensor, change distance centimeters. So these two will essentially function as at the exact same time, right? When the response is triggered from the ultrasonic sensor, that will cause for the counter to add 1, or in this case, it'll cause for the motors to roll. So how are we going to get the motors to roll? Well, we have two motors in our project, as you can see from the fully assembled crawly robot. And so the most efficient thing to do would be to do move tank. So move tank is what is going to drive the entire robot forward, right? Because it has two motors, so you want a two-motor function. This is a two-motor function right here, okay? So this is the number of rotations that the actual motors will be on for once they're triggered by the ultrasonic sensor. And for our purposes, we're going to set this to number 2. We'll do 2 rotations, okay? This is also the set distance that has been included as part of the kit. And the power of the two motors will be 75 and 75. So you're going to set this power to 75 and 75. Now, the really cool thing about this product and about this program is that you can customize any one of these choices. So let's say that you let's say that you don't think that this is fast enough or gives you enough distance. The 2 rotations don't give you enough distance to measure the distance that you want to measure. Well, you can set this for, let's say, 10 rotations. And you can measure out the distance for 10 rotations. And then you can figure out your distance that way. Or let's say you think that this is going too slow and you want to crawl faster. Well, you can set this to 100 power. Or let's say perhaps you want your crawly to do circles for whatever reason. Well, you can set one of the motors, the left side, to, let's say, 25 power, this one to 100 power. And because the left side has less power than the right side, well, then the crawly robot will actually begin to crawl in a circle. That's why the name of the robot's actually crawly in the first place, because the whole purpose of the robot is to crawl forward. Okay. And so the important thing to again realize is that this is a loop, right? So it's triggered by this ultrasonic sensor, and then it sends in a response to move the wheels of the tank, right? And so you're going to want to make sure that just like how we have a 1.2 second delay here before the start of a new loop, you also want a 1.2 second delay start before the start of the loop over here. So all you have to do is add in the time function one more time, put it in right here, set this to 1.2. And now these two programs will run simultaneously beside each other. And every single time that you scan an object, not only will you have the coding or the counter program running, which will count the objects for you, but you'll also have the crawly crawling forward. And again, a lot of these things are customizable, right? So let's say that you're scanning objects in pairs of 2. Well, you can change this B value right here to 2 in order to actually scan 2 objects at a time, right? You grab 2 marbles in your hand and you scan, right? You want them to be counted as 2. Well, here you go. You can change this to 2 and it'll now count it as 2. And so then it'll take 0 right, plus 2, and you'll get 2. And then it'll put that out over here. This will come 2. Then this will set in the signal 2. Boom, 2 comes into here when this is scanned. 2 plus 2, 4. Boom, scanning objects by pairs of 2s, right? Make sure also, sorry, for the sake of our robot, that these ports right here are set on A, and this port right here is set on D, okay? And then lastly, the only other thing that you want to make sure is that this is all done as you see on your screen, okay? These things are set on infinite, these are set on 1.2, 1.2, these are set on 75 power 2, port D and A, because this is what is included in the building instructions. But again, I encourage you to try out your own combinations with the Crawley robot. So, you know, maybe you want to put these in different ports, maybe you want to set the powers of the motors differently. There's obviously a lot of other cool things that you can try. Maybe let's say that you don't like how fast the response of the counter is. Maybe you're counting heavier objects, right? And you need more time before it counts again to move your hand out of the way. So let's say you can set this up to 2 seconds, 3 seconds, right? However long you really need. It's your ability to play around with the robot and really customize it to the fullest extent. And that's really the awesome part about your Crawley robot. Your Crawley robot is fully customizable. You can do whatever you want with it. And really, you can change the program and manipulate this basic counter that you see right here in order to suit your needs. Something that, you know, other products on the market don't currently offer you right now. So hopefully you enjoy your Crawley robot and you really learned the basics of the counter here. Just to recap, so you fully understand the counter once more and how this counter works. So first, we scan an object in front of our ultrasonic sensor, right? And it counts, and it sends in, an input to the variable, right? Now the variable when we began was 0, so it's going to send in the input for variable 0 to be added plus 1, right, because it begins at 0. And then it sends in this 0 plus 1 to this new variable over here. It writes out the new variable, which is 1, right? Then this function right here reads the new variable, which is 1. It converts that new variable into text and displays it on the screen, right? Then, as this is displayed on the screen, because this and this happen simultaneously, it will also leave a little sound or a beep. Then there will be a 1.2 second delay, the loop and the ultrasonic sensor will be ready once more for you to scan another object. The one that we had as our new variable here gets sent all the way along this loop back over here, and this now changes to 1. Okay, so then now this is value 1 or variable 1. Another thing is triggered or responded. It takes 1, which is the variable, from here, right? It puts this value into A, right? 1 plus 1 is now equal to 2. 2 is the result, right? 2 is the result. So the result is plugged into this, which reads this result. It reads this result, right? This then also takes this result, converts it to a text on this function right here, right? Then it sounds out a chime as it reads the result and displays the result, and there's a 1.2 second delay before you can use the sensor again. And this program down here runs simultaneously, so every single time the sensor counts something, the robot's tank wheels are triggered to move, so the robot moves as soon as something is sensed by the sensor. There's a 1.2 second delay, and then again it restarts this. So this essentially, if you want to look at it this way, this is the trigger. The ultrasonic sensor is the trigger for the variable, or the tank moving wheels, right? The variable then gets triggered, and then it does this math operation right here, which is an addition, a simple addition of 1, right? It completes a simple addition of 1, and then it goes and it writes out the new variable. This is where a new variable is stored, right? This is where the new running count, which we see on the screen, is stored. This, which is stored on the screen, is then read, right? Because we're not changing the variable anymore, it's just simply read and then displayed on the screen. A chime sounds, and the program is complete. So, this is how to program your Crawley robot in order to create a simple counter within the programming and to understand the basics of the Crawley robot. I hope that you enjoyed this tutorial, and I hope that you have fun creating your own inventions with your Crawley robots. The last detail that I want to mention before I go is that, as you can see in this little display function right here, there's also an X and a Y. Now this X and the Y controls where you actually have the number displayed on. So for the sake of our purposes, just make sure that you have this as 8060. The reason why this is 8060 is because 8060 is essentially the orientation on the screen. So imagine that, for instance, we have a box, right? So I'll just use this as an example. I'll use this loop as a example, right? So this is our box. Imagine this is our box, right? And so this means that we have x coordinate 80, so we'll say x coordinate 80 is right here, and then y coordinate 60 right here. So this is where the actual number that we get will be displayed, alright? This is also the size of the font, so you can change it, right? This is the biggest, this is smaller, this is normal. You have a lot of customizable options, and really this is all the controls in your hand. If you don't like the sound of the chime, you can change the sound of the chime. So maybe we can go Lego sound files. Let's change this to perhaps let's change this to something else. Let's say maybe we want the sonar. So every single time we scan an object, we'll hear that. I hope you enjoyed this tutorial and have fun programming your EV3 Crawly robot.